Hi all, welcome back to ugcnet. In this video, we'll be going through the different phases of a compiler, or we can say the structure of a compiler. The block diagram given here represents the different phases of a compiler. Here you can see the compiler is divided into 6 different phases: the lexical analysis phase, the syntax analysis phase, semantic analysis, intermediate code generation phase, code optimization phase, and finally the code generation phase. And among these 6 phases, the first 4 phases is known as the analysis phase. Analysis phase. And the remaining 2 phases is known as the synthesis phase. Thus, we can say that the phases of a compiler is divided into 2 parts. The first part consists of the first 4 phases and it is known as the analysis phase. And the second part consists of the last 2 phases and it is known as the synthesis phase. The analysis phase is also known as the front end of a compiler. Front end of a compiler. Similarly, the synthesis phase is known as the back end of the compiler. Okay, and here we can see 2 more things. First one is a symbol table and the second is the error handler. And about this symbol table and error handler, we will be going in detail in another video. In this video, let's focus only on this analysis phase. In the analysis phase, the source program is taken as the input, and after all these 4 phases, that is after this analysis phase, we will get the intermediate code as output. And this intermediate code will be then passed over to the synthesis phase. We will be seeing this synthesis phase in the next video. In this video, let's focus on the first 4 phases. So let's start it. So in the analysis phase, it consists of 4 phases. First one is the lexical analyzer. Second one is the syntax analyzer. Third one is the semantic analyzer. And finally, the fourth one is the intermediate code generator. So to the first phase, we will give our source program as the output. And this source program will be translated to different forms after each of these phases. So now first we will go to the lexical analysis phase. Lexical analysis is done by a lexical analyzer. And this lexical analyzer have 2 more names. One is scanner and the second one is tokenizer. I will tell you why these 2 names came. So now just understand that lexical analysis is done by a lexical analyzer and this lexical analyzer is also known as scanner or tokenizer. So this lexical analysis, this method is also known as scanning as well as tokenization. Now what's the task of a lexical analyzer? This is our lexical analyzer. The lexical analyzer will take the source program as input. The source program, it can be written in some high-level languages. So the lexical analyzer will take the source program and it will convert the source program into tokens. That is a stream of tokens. Our source program will be having a stream of characters and those stream of characters will be converted to a stream of tokens. For example, let's assume that this is a statement in our source program. Position is equal to initial plus rate into 60. So what the lexical analyzer do is, lexical analyzer first scan this input from left to right, character by character, and it will identify some meaningful lexemes from this statement. Here you will be going through some terms like lexemes, tokens, as well as patterns. You will be going through these terms in detail in coming videos. For the time being, just understand that lexeme is a meaningful stream of characters which we can convert into tokens. So the lexical analyzer will find the lexemes from the input source program or this statement, and those lexemes will be converted to tokens. And this conversion is based on some rules, and that rules is known as patterns. And what are these tokens? Tokens are the building blocks of a program. That means there are different types of tokens. For example, identifier is a token. Identifier means the variables. For example, X is a identifier, rate is a identifier, Sum is an identifier. All these variables that we use in our program is an identifier. Now, the keywords are a type of tokens. Keywords means the words which are predefined. For example, int. Int is a keyword which is a data type. Float is a keyword. If is a keyword. Break is a keyword. All these words which are having a predefined meaning, those words are known as keywords. So, keywords is a token. Then constants is a token. Constants mean some integer values. It can be integer 60 or it can be some float value. I mean decimal value 60.0. All these are constant values. Now another kind of token is operators. For example, additional operator, subtraction operator, multiplication, less than equal to, greater than equal to, all these are examples of operators. And the last type of token is punctuation. Punctuations means comma, semicolon, parenthesis, braces, all these are punctuations. So these are the different tokens that we can see in our program. Now the role of a lexical analyzer is to scan our input character by character and identify the lexemes inside this input and then convert those lexemes into corresponding tokens. For example, in this statement, the term position will be considered as one lexeme. The operator equal to will be considered as another lexeme. Initial is one lexeme, plus is a lexeme, rate is a lexeme, star is a lexeme, and finally the number 60 is a lexeme. So what the lexical analyzer do is, it will match these lexemes to the corresponding token and it will produce a stream of tokens as output. The position is a token and it's a variable name. So it will be converted to which token? Here, token identifier. Okay. So the position will be considered as identifier. Now this equal to is an operator. So it will be considered as an operator. Next is the word initial. Initial is a variable name. So it will be considered as an identifier. Then comes plus sign. Plus is an operator. So it will be considered as an operator. Then comes the term rate. Rate is an identifier. Why? Because rate is a variable name. So it's considered as an identifier. Next is the sign star. Star means multiplication operator. So it is an operator. And finally, the number 60. 60 is an integer. So it's considered as constant. So here we can see that 1, 2, 3, 4, 5, 6 and 7. So the input statement is converted to 7 tokens. So this is the task of a lexical analyzer. And one more thing you have to note is, these tokens will be represented in a form token name, comma, attribute value. Attribute value means some additional information about this token. And this token will be saved to a symbol table. Now what is this symbol table? Symbol table is actually a data structure just like a normal table. Here the token name will be there and here the attribute values will be stored. So coming back to our example, position is equal to initial plus rate into 60. Here the position will be converted to a token identifier and this identifier will be saved inside our symbol table. So it will be having the form token name, comma, attribute value. Here we write 1 as the attribute value to denote that this identifier, that is position, is saved as the first entry to the symbol table. So the term position will be converted to the token ID, comma 1. Now the next lexeme is equal to operator, that is assignment operator. Now this assignment operator will be converted to another token. It's actually the token operator, but for convenience we are writing it as equal to itself. Now just understand that these operators, plus, minus, etc., those kind of operators does not require any attribute values. So we can write the equal to sign just as it is. Okay. Now the third one is initial. So initial is an identifier and we'll be storing it as the second entry of the symbol table. So we have to write it as ID, comma 2. Now the next lexeme is plus operator, that is addition operator. So we will write it as it is. We can just write it as plus. Now the rate is an identifier. We will be entering it as the third entry to the symbol table. So we can write it as id, 3. Next one is the star operator, that is multiplication operator, and we are writing the multiplication operator as it is. And the final one is the constant value 60. 60 also we are writing it as it is. Okay. So here we can see that only those identifier values we are writing it as id, and we are giving the attribute value, that is it is pointing to the position of this token inside the symbol table. So that's like a pointer to the symbol table. Thus here we can write a source program position equal to initial plus rate into 60. This statement will be fed to the lexical analyzer, and lexical analyzer will convert this stream of characters into a stream of tokens. That is, this will be converted to id, 1 equal to id, 2 plus id, 3 star 60. This is how we represent our tokens. So here we can see that the role of lexical analyzer is to scan the input character by character, and that's the reason why we call the lexical analyzer as scanner. Also, the role of lexical analyzer is to convert this stream of characters into tokens, and that's why it is also known as tokenizer. Okay, so the two main roles of lexical analyzer is scanning as well as tokenization. Okay, so now the second phase of a compiler is syntax analysis. Now let's see what's a syntax analysis. Here syntax analysis is also known as parsing, and this syntax analysis or parsing is done by syntax analyzer. This syntax analyzer is also known as parser. Now what is the input to the syntax analyzer? We have already seen that the stream of characters, that is our source program, is fed to a lexical analyzer, and the lexical analyzer produces a stream of tokens, right? Till that we have already seen. Now this stream of tokens will be fed to a syntax analyzer. And what will be the output of this syntax analyzer? Syntax analyzer is used to give a grammatical structure to these tokens. So the syntax analyzer will take these tokens as input, and it will give a grammatical structure to these tokens. That is, these tokens will be represented as a tree. You already know what is a tree, right? This tree is known as the syntax tree, or it is also known as parse tree. And in this syntax tree or the parse tree, the intermediate nodes, these are the intermediate nodes, and these are the leaf nodes, right? I hope you already know this. So these intermediate nodes will be having operators, for example, plus, star, etc. So these intermediate nodes will be holding the values of operator, and these leaf nodes will be the arguments of this operator. For example, we are having a statement z is equal to x plus y. In this x plus y, the operator is plus. So our intermediate node of the syntax tree will be plus, and the two arguments of plus operators are x and y. So the leaf nodes will be x and y. Now we are storing the result of x plus y to z. So the operator is equal to, that is assignment operator. So we will use the assignment operator as the intermediate node, and the two arguments of this assignment operators are z and x plus y. So one argument will be z and the other argument will be x plus y. So this is how we represent a syntax tree. So here you can see that the intermediate nodes are operators and the leaf nodes are the arguments of these operators, right? Now we can go back to our previous example. That is the output of a lexical analyzer. Here we can see this is the output of the lexical analyzer, that is a stream of tokens. These tokens will be fed to the syntax analyzer, and this syntax analyzer will convert this to a tree-like structure. So let's see how this will be converted. So here we can see that there are three operators. First one is assignment operator, second one is plus operator, third one is star operator. Among these three operators, we know that the highest precedence is for the star operator, that is multiplication operator. So first we have to consider the multiplication operator, that is ID 3 multiplied with 60. So that will be drawn as our first node, multiplication. So there are two arguments for multiplication. First one is ID comma 3 and the second one is 60. So ID comma 3 and next one is 60. Now we have completed evaluation of this much part, and now it's clear that the second operator that we have to perform is addition. Addition is done over two arguments. First one is ID comma 2 and the second argument is the result of the previous operation, right? We are having a plus operator with two arguments. One is ID comma 2, that is the first argument, and the second argument is the result of the multiplication. That means here. So we have completed evaluating this much portion, and the last operator that we have to perform is assignment operator. And here this assignment operator is having two arguments. One is ID comma 1 and the second one is the value we have computed till now. Okay. So this can be depicted as assignment operator. One argument is ID comma 1 and the second argument is the complete result that we have evaluated right now. Okay, so this is the output of syntax analyzer. This is known as the syntax tree or the parse tree. Syntax or the parse tree. Okay, so first the source program is converted to stream of tokens, and then the stream of tokens is converted to syntax tree or the parse tree. Now the third phase of the compiler is semantic analysis. So the third phase of a compiler is a semantic analysis, and in semantic analysis we will be checking the semantics or the meaning of our program. So here the main task of semantic analysis is type checking. For example, suppose we are adding the values of x and y. So here in order to add x and y, both x as well as y should be of same type. For example, x should be an integer and y should be an integer. Then only we will be able to add it. Suppose x is an integer and y is a float, then the result will be either an integer or float depending on the value in which we are storing it. Suppose z is initialized as integer, then the result will be stored as integer. Suppose z is initialized as float, then the result will be stored as float, right? So actually what we are doing there is coercion. That is, we are automatically converting a float to an integer or an integer to a float. For example, in case of our previous example, suppose here we have declared this position, initial and rate. All these three variables are declared as float. Just assume that we have declared all these variables as float. So here we are doing the multiplication operator over a float value and an integer value. Here 60 is an integer value. So in order to perform this operation, we have to convert this integer value 60 to corresponding float value. That conversion is known as coercion. And after that conversion, we will multiply that decimal 60 with rate. Okay. So that is what we do in the third phase of the compiler, that is the semantic analysis phase. And the output of the semantic analysis phase is a syntax tree itself, but we call it as annotated syntax tree, or we can also call it as annotated parse tree. The only difference between an annotated parse tree and a normal parse tree is that in case of an annotated parse tree, the type checking and coercions have also been done. As I already told, position, initial, rate, we are assuming that these three variables are float and 60 is the only integer value here. So the 60 must be converted to float. Then we have to do the multiplication operator. So here, instead of writing 60 directly, we will be converting this 60 to float, that is int to float, and that value will be multiplied with ID 3. Now this syntax tree is known as annotated syntax tree or the annotated parse tree. And finally, this annotated parse tree will be sent to the fourth phase of a compiler, that is the intermediate code generator. And the task of the intermediate code generator is to produce an intermediate code. Actually, there are different types of intermediate codes, and we will be studying in detail about these intermediate codes and different types of intermediate codes in the last modules. Here we will be considering just one type of intermediate code, that is the 3-address code. So the fourth phase of compiler or the final phase of analysis part of the compiler is the intermediate code generator. And the input to the intermediate code generator will be the annotated parse tree, and the output will be the intermediate code. For example, 3-address code. Now, why we are converting this annotated parse tree to an intermediate code rather than converting it directly to the target code? Because this intermediate code is much easier to produce, and also it will be easier to convert this intermediate code to the target code rather than converting the syntax tree directly to the target code. That's why we are using this intermediate code in between. So let's consider our previous example. Here we can see that the output of the semantic analyzer is a annotated parse tree. Now we have to convert this annotated parse tree into intermediate code. That is our 3-address code. For that conversion, our first step is to convert this integer value 60 to a decimal value. That is, we have to do the int to float conversion of 60. So let's assume a temporary variable t1 is equal to int to float of 60. And in 3-address code, in order to store the result, we will use some temporary variables. Okay. So first step is to convert the 60 to a float value, and we stored it in variable t1. Now we can see that this much portion, these values will be stored in the temporary variable t1. Now we have to perform multiplication over variable t1 and id3. So that will be our second step. id3 multiplied with temporary variable t1, and then we have to store this result into variable t2. Another temporary variable t2 is taken, and this much value we will be storing in the temporary variable t2. Now what we have to do? We have to do the plus operation, that is addition of variable id2 with t2. Okay, so id2 added with t2 will give you another variable t3. Now finally what you have to do? Now this much portion, these much values are stored in variable t3. Now what we have to do is we have to assign the value stored inside t3 to id1, right? So just id1 is equal to t3. Okay, so this is our 3-address code. So this is our intermediate code. Here in this case, you can see that in each of the instruction, there is only one operator performed. Okay, we cannot do addition as well as multiplication both in single statement. In each statement, we will be performing only one operation at a time. Okay, so that's a property of a 3-address code. And also, here you can notice one more thing. In each of the instruction, there will be at most 3 operands or 3 variables. That is why we call it as 3-address code. So that's all about the analysis phase. Remember, the analysis phase starts with the lexical analyzer, and to the lexical analyzer we will be giving the source program, that is the stream of characters will be given as input to the lexical analyzer, and the lexical analyzer will convert this stream of characters to a stream of tokens. So here you can see the stream of tokens, and then this stream of tokens will be fed to the syntax analyzer. Syntax analyzer will check the syntax of our program, and it will report any syntax error found. Those portions we will be covering in the second module. Second and third module consist of the syntax analysis, and this syntax analysis is the most important phase of a compiler. Okay, and once these tokens are fed to the syntax analyzer, it will produce the syntax tree or the parse tree as output. And this syntax tree will be fed to the semantic analyzer, which checks the meaning of the program, and it will check for the logical errors in the program. And the important task of semantic analysis is to perform the type checking. And during type checking, it will be performing some levels of coercions. Thus, the semantic analyzer will produce an annotated parse tree or an annotated syntax tree as output, which is then fed to the intermediate code generator to produce the intermediate code. So that's the output of an analysis phase. And the analysis phase is also known as the front end of the compiler. So to the front end of the compiler, we will be giving the source program as the input, and the front end will produce the intermediate code as output. Okay. So this intermediate code will be then fed to the back end of the compiler. That is the synthesis part of the compiler. and the synthesis part we will be learning in the next video. Hope you all understood the analysis phase of the compiler. So see you soon in the next video. Thank you.